Good morning, afternoon, or evening, everyone. Thanks for being here today. My name is Chris Wallander, and today we will be discussing the considerations of success concerning test automation code quality. Our agenda today is going to cover a bit about who I am, what considerations of success means, some pre-code examples, and then finally, what most people like talking about, the code itself, script development. Myself, I'm the principal SDET and test automation architect for TaxAct. As Susie's already told you, been working in the quality assurance industry for around 13 years, 10 of it with automation, quality assurance, etc. 5 of it with DevOps, working with Team Foundation servers, Team City, different continuous integration pipelines, and code infrastructure. A little bit about myself outside of work. I'm a machine learning and artificial intelligence practitioner. I actually do that a lot more externally than I do work internally. I build video games, robots. I even do some medieval blacksmithing. In the picture here, you can actually see myself wearing some of the armor I've made, and that same suit of armor is right here. So what actually makes good test automation code? What folks may often not realize, a large part of your code quality can be determined even before you write your first bit of code. Often your test cases or even the design of the application under test can play a huge part in what we write, let alone if we're automating the right test case or not. With some of these considerations, we're going to talk through today the test case design and application under test, some ISTQB jargon, testability, controllability, observability, your test case return on investment, and then finally, we're actually going to get to some code. Now, the code today is going to primarily be in C#, but it's meant to be agnostic. You can apply it to any programming language. In the previous slide, we mentioned that code quality can be at risk before it's even been written. A test case not explicitly written to be automated is often not well suited for automation. Early in our careers, a test case written may have been to merely walk through the UI like an end user would, trying to see if the user could complete whatever business logic we wanted to make sure they could do. Inherently, this is not a bad test, but when we think about our application or collection of applications under test, how brittle is that test case going to be? How many different teams' code is being touched? Now, obviously, not everyone is going to have this problem. It all leads back to how your organization and your application under test is designed. Quickly, these types of considerations, dependencies, and goals for automation can grow pretty exponentially. Why are you wanting to automate that specific test case? Is it, once automated, returning value that pays for its maintenance cost? What is the current state of the application? Can we get in there and change the state of the application as needed for automation to test against? These are just some of the early questions to ask. First, let's talk a little bit about some automation project management. No matter if your automation is codeless or code heavy, a script that is quick to write is not always the right one to use. Sometimes they're expensive to execute, difficult or costly to maintain, or maybe debugging them is an absolute nightmare. Automation written with low maintainability in mind, while it can be set up very quickly, often leads to massive time investments later. This, of course, all depends on your application lifecycle and the rate of change in your application. When deciding how to write these test scripts, we should heavily consider the test case's return on investment. A common thing I see in the industry is the scenario of wanting to put automation around a legacy system. Honestly, this is a pretty solid goal if it's planned well. A challenge here is in knowing what the old system did, its rate of change, and of course, its accessibility of setting up and tearing down test data within its bounds. Newer systems tend to have the same considerations, but you don't need to refactor the application under test to put them in, but instead should be planning to put them in from day one. If you don't, then you're back in the same scenario as the legacy code, needing to enhance the application in order to increase your testability. In both scenarios, it comes down to seeing how far you can get with the limited runway available to you. And in doing this, knowing your requirements is going to be critical. Without easily understood requirements, it is next to impossible to know what you're asserting against, and a test case that is unclear should never be automated to begin with. Now, when we're looking at sizing things up, we want to know if this is a legacy or new project, as refactoring almost always takes more time. If the app is already built, we may not have the testability we need at first, setting up or tearing down test scenarios in the application. This will limit the types of tests you can run against the application and sometimes force you into brittle, long-running tests. Are the requirements available? If not, we may not be able to write tests that are clear and concise. This can lead to downstream issues with debugging. If you don't know what you're looking for, how do you know what to assert against? If you don't know what to assert against, how do you know what you're looking for? How often will the application change in the near term? This can lead towards tests failing due to lack of maintenance and will require you to spend more time updating your scripts. An example of this would be your application needing to rely on another team that owns an authentication piece for your app. If they make a change without communicating to you, or you're not using something like service virtualization, any of their changes can break your code, making maintenance a big nightmare. It can even push you into an unplanned automation refactor late in the SDLC as you attempt to abstract out your code. All of this we are talking about can be used to calculate a return on investment. Here's a list of things that can be documented and calculated out to do an ROI. As you can see, it's a painful list for those that don't enjoy math. My recommendation here is you can put this stuff into an Excel sheet to do the math for you once. Abstraction. In short, it's your manual effort, your automation investment, and automation execution calculated out in order to get a percentile. Depending on the needs of your company, you can calculate this down to man hours, story points, or even the fiscal cost of savings of your automation, depending on management's needs. And as you can see in the list here, and this is kind of small because there's so many of them, you can get down to a project level or even an individual test case with this ROI to see whether or not it has value to even automate with the limited time you have available to you. With everything we've discussed so far, it's ultimately going to drive what type of code you'll be creating. The state and testability of the application will determine how deep you can go, and in essence, potentially force you into specific types of testing. A lack of requirements or application state observability can force you into writing longer end-to-end automation. While not necessarily a bad thing, each type of test has its place in the agile testing lifecycle. We want to always be striving to use the right type of test in the right scenario. Another example, if your application has no means to change its state that the automation can leverage, you're forced to write a brittle end-to-end test. This could be all right if your application doesn't change much. Linear automation can be written, or even simple record and playback can be used, as the need for maintenance may be non-existent once the script is successful. However, if your application stack is crossing multiple teams or even around high change areas, you now need to consider how deep code your testing is and the different forms of abstraction to allow you to maintain them when change invariably occurs. Some of the different types of testing that we can have: white box, which you're able to look inside, see what's changing. Black box, you're just testing from the outside looking in. Acceptance testing, which may be along the lines of, can the user perform the action that the product team or management decided? Each of those fit somewhere in your cycle. None is specifically better than any other. All right, let's get into some of our code design principles. The principles on this slide are in no specific order of importance. Some are very small, while others can be quite daunting. First up is arrange, act, assert, or sometimes known as the AAA approach. It is a unit testing readability principle and matches similarly to the Gherkin syntax of BDD. The concept in this approach is that someone reading your code can easily tell the order of events. In this, arrange is for any of your setup, act is for whatever is generating your response or behavior you're asserting against, and finally, your assert is merely checking at the correctness of whatever the act stage harvested. Here you can see an example of a simple test written in C# with some comments put in for readability. The important part here is the order of operations. The comments are actually optional. Under arrange, we initialize our variables and values. Here you can see first number, second number, expected result, and the calculator object. We then, under act, perform the sum calculation, and store the results off in a variable, in this case, double result. Finally, we perform the assertion against the stored result. The AAA approach is a good basic principle to start with and is even widely used amongst developers today to write unit tests. They use this to make their code easier to read. Next, we have the DRY principle, standing for don't repeat yourself. The goal of DRY is to help with long-term maintenance. If you're using page object models, step definitions, action or replay libraries in your automation, you're already taking part in DRY today. DRY is a simplification of the abstraction principle of software development. Basically, in short, if you have to write a piece of code more than once, pull it out into a method so you don't have to write it again. This serves a double purpose. Not only does it allow you to reuse complex logic quickly, but later, if you need to change it, you can update it in one location rather than once per test script. The more scripts you have going down the same route, say you're using Selenium, the more important this becomes. Here we have an example of something we can dry out. Currently, as part of a page object model, someone is performing a registration. For their test case, they are coming in and line by line calling out the actions. Navigate to, going to the username text box and sending keys, password text sending keys, adding a mobile number and email address, clicking on a register now button, and wait until load. We can dry this out for reuse in two ways. Combining these actions together into a user action method called register as, which you can see there on the right, then creating a customer class object to help drive and control the test data. Here's what that method may look like. In this example, we are using a navigate to method, which is abstracted elsewhere as well, which likely contains page load and timing logic to make sure our Selenium lands on the desired page. After that, we are merely interacting with our elements as normal. We are also taking the customer class object as an argument, so we can keep things nice and simple for whoever is writing the tests after we've set this abstraction up. Sometimes it may not be us. Here's what that would look like implemented. Used together inside of your test method. There are, of course, ways we can dry this out further, especially if your framework allows for test initialize calls. Let's take a look at what that might look like. As you can see here, we have used the test initialize to create our page objects needed for the entire class, and even created a default customer. The test now only contains exactly what is needed to run. What you can see here is we're defaulting and using a generic username, a password, a phone number, and an email address. And in this particular system, you might see a pre-test method. You might see test initialize for C#. It will use this every single time for every test. That customer object is now readily available. In the test method, we can see that in particular needs, they can now update for whatever that particular test needs, that customer object. And if they don't need to update it at all, they can leave that out. Dry can be scaled up pretty heavily based on your need. If you have a large enterprise scale system, consider breaking your enterprise down into app-based abstractions for IntelliSense. This will allow other automators to find things significantly easier. That way they can read and make the whole project more approachable. This means less onboarding time and less time spent understanding the code that was written, something that's been called cognitive debt in the industry. Another major helpful item is to consider breaking the application down into user-centric actions. To do this, we have three types of actions an individual can do while on a singular page. Basic actions, which are interactions with a singular component, like an end user would. Clicking, typing, hovering, etc. Fetch actions, which are just harvesting data for you from the page, no more, no less. And finally, composite actions. They're any combination of basic and/or fetch actions to handle end-to-end user interactions on a page. An example we saw earlier was the register as method. Next up is the Keep It Simple Simon principle, also known as the KISS principle. The idea here is to merely keep your designs as simple as possible while still meeting your requirements. For this, you need to sit down and produce some reasonable complexity targets. Some examples below are powered IntelliSenses, code readability standards, such as those found in programming guides, or class object models for your test data. Remember, a cost is being paid while you design your automation, and the further left you can pay it, the cheaper it is for you, the other automators, and even your organization. Just as what Justin said earlier about shifting left. Next up is the you aren't going to need it principle, or Yagni, probably one of my funnest ones to say. Yagni is taken from extreme programming, and it ultimately means to only implement something when you need it. One of the things to remember with Yagni, it must be practiced with the other principles we are discussing here, or it can become an anti-pattern very quickly. An example of this would be to merely implement the fastest work you can get in the system, even if it's not built for maintenance in mind. This is all fine and well, but Yagni is heavily reliant on continuous refactoring. This means when you put in your second test script, you would need to go back and refactor your initial test script for maintenance and create all of your abstractions. Often people will not consider this, or someone else who is unfamiliar is adding that second script. This is how it can spiral out of control and become the anti-pattern. Ultimately, when the continuous refactoring is not performed, it's the same as building your framework without any reuse at all. As part of Yagni, it is taking into consideration that you also need your endgame maintenance considerations as a requirement for your project. Here's a little bit of a simplification of Yagni for automators. Yagni, like we mentioned before, tends to lead people to avoid abstraction because it takes longer to code when they can just put it in the test script itself. A simplification of thinking here for Yagni is to only map what you need for automation when you need it. So for example, with Selenium, only create classes when you need them or create webhooks to web elements as you use them in your tests. If you have a button that you can click on the page, don't automate it unless you need it. Otherwise, leave it off the page. That does mean in your considerations for sizing any of your work, you always have to consider adding the abstractions and webhooks each time you go to add a new script unless the route has already been mapped. Let's talk about small, atomic, and autonomous. These are three principles I picked up while working with Sauce Labs. Each represents a simplification of a much deeper coding principle. Small is the concept that your tests are short in execution and as much to the point as possible. This means taking the shortest possible route to set up test data, navigate to your validation point, and finally perform your assertion. The goal of this is to give you very fast executing scripts that plug in cleanly to continuous delivery pipelines. Industry standard for a UI test is around 2 minutes or less. Atomic is about making sure your test is targeted. It needs to be clear what you're testing so someone else can debug it if necessary. This one is all about debugging costs. An anti-pattern to this is tests with multiple asserts. Which one failed? Why did it fail? We want to get down to reading the test method name, seeing red or yellow or green, and then reading the error message your framework gives to tell the developer a rough idea where to start looking in his code. Remember, it's not just about our debugging as automators, but also the developer debugging the application as well. Autonomous is about parallelism and keeping your test scripts self-contained. If they rely on information or test data set up from other tests, now you must run them in a specific order every time or the test would fail. 10 tests running end-to-end takes far longer to execute than 10 tests running in parallel, even if the individual scripts are a little longer in execution. In addition to this, it's far harder to determine what failed in a chain of tests as compared to a singular self-contained test. Readability standards aim to make your code read like a book whenever possible. Code that is easy to read is easier to understand, and therefore easier to troubleshoot. Not only is it easier to troubleshoot, but it also becomes quicker to bring in new individuals to the product, as the code is easier to read and understand. Every coding language has a coding guide. And I'll be providing some links to several of the popular languages later in the slides. These coding guides are a wonderful place to start, and then you can modify them as needed. Make sure any modifications you make are well documented though, so they're easier to communicate to your organizations. An example of the readability standards actually goes back to the dry we were showing earlier. And let me bring that back up real quick and I'll show that off. Here, we can tell exactly what each of these elements are by looking at the 3-character suffix at the end of them. We know username is a text box because of TXT. We know register now is a button because of BTN. And we know what register now or register as is supposed to be accomplishing based on what we've named it. Some other examples of readability might be using strongly typed variables, such as int, string, var, or a class name to make it easier to read for people. Correct usage of Pascal or camel case for properties, method names, etc. Last but certainly not least are the solid principles. This is an absolutely huge topic and could easily fill an hour or more with a deep dive. The solid principles are software development principles aimed around making clean, sustainable code. For anyone that's taken the time to start designing their own automation framework, these are the next steps to consider in your own continuous improvement. The simplest of these principles, the single responsibility principle, otherwise known as the SRP, is about making sure your classes, methods, and objects focus on doing only a singular thing at a time. An example of this would be a page object model focusing on interacting with just its one page at a time, or a method designed to harvest data from a page and present it forward. If that method was modifying anything or doing anything else other than returning the data, it would actually be in breach of this principle. The SRP is probably the single most important of these for an individual getting started with test automation. The other 4, however, represent good next steps for individuals looking to grow their frameworks in a sustainable manner. Open closed is about how you change code and when you change code. List-off substitution is basically based around the concept of I should be able to interchange classes based on their inheritance level. Interface segregation is about helping people control what methods are being used at which time and which properties are being required when you're putting them in. And dependency inversion kind of goes back a little bit and ties kind of close to list-off substitution in using methods. All of these are great for a next advanced topic. And again, there'll be a link later on as where to find some of this information. Ultimately, the standards we covered today are the tip of the iceberg and should go to show individuals that while it may be easy to begin writing code, it takes a bit of planning to create well thought out sustainable automation. It is not something you'll get right on the first try. The secret, however, to all this is the willingness to continuously improve. Somebody starting off is going to look at those end-to-end tests and they're going to think they're great. We'll even see managers who will see the record and playback tools and instantly fall in love with them because it allows them to start quickly. One of the things for us as automators is to understand that there is going to be a maintenance cost depending on the choices we make, and to push our organizations to think, can we pay this cost earlier and cheaper? If we don't, our projects are going to eventually capsize, and it becomes at that point very difficult for us to keep up. That being said, we covered a ton of information today at a very rapid speed. Thank you very much.
Thank you, Chris, for that quick tour through the code design principles. And as you said, a lot of really great information in there. And we did cover it quickly, which means we have a decent amount of time for Q&A. So certainly anyone who wants to go back to any of that content, get more detail on anything that Chris just shared with us, please do share those questions and we will run through as many of them as we can in the next 5 to 10 minutes here. And Chris, the principles you were just sharing, it was making me think of an event that we hosted the other week, and we had a bunch of feedback from the audience saying that automation isn't embedded at their organizations, right? A lot of attendees were sharing that if they individually were to leave their company, test automation wouldn't survive, which I'm sure is not a power that they want to have.
Oh, goodness, not.
I wonder if that's true for anyone tuning in today. Feel free to share in the chat sort of where that stands at your company. But certainly the code design principles that you just shared with us sound like they'd be really helpful in starting to address that danger of sole ownership or having this not be transferable.
Absolutely. The entire purpose of these principles and how you apply them is actually about bringing people with limited coding experience into test automation. In fact, a lot of these can loosely even be applied to codeless automation. For example, if you have a record and playback tool, dry would represent using pre-canned actions, if you would. Say you need to navigate through a sign-in page. Are you going to do that for every single test script? Say you have 10 test scripts and the sign-in route changes. You now have to do that each individual test script and update them. Your maintenance costs get out of hand real quickly. But if you can create a pre-canned one, Lego, as we like to jokingly call them in the office, you can now update that one piece and then let it flow downstream to all the rest of your tests. Saves you a lot of time in the long run.
Yeah, absolutely. It looks like we have a little bit of feedback in the chat here. 50% true that the test automation wouldn't survive departure, but only because we have 2 people working on it instead of 1. I hear you. I hear you. We've got a few questions coming in, Chris, talking about sort of automated versus manual. There seems to be a theme here. One that is in the Q&A here, and I'll just read it out for us, asking, out of the total bugs found, manual and automation, in any project, in your experience, what % of bugs are usually found through that automated testing versus manual? And do you think it's possible to totally eliminate manual testing?
That's actually a really good question. Thanks for whoever asked that. One of the things with automation, the act of automating is going to actually find more bugs than the actual automated scripts find themselves. In automation, there's a concept called the pesticide paradox. So say as part of your sign-in, you find that you're only supposed to allow 15 characters for a username, and we're allowing more for some reason. You create an automated script that tries 16, and if it finds out it can, it throws a defect. You find it as you're creating it the first time. You then put the script in, and then if it's ever brought back, the script's immediately going to call it out. The idea of automation, especially when paired with continuous integration, continuous delivery, is not so much that your automation is finding new defects as it's preventing. The concept here is that should, say, they deploy to a testing environment, your script runs, finds the defect, rolls it back. Now, that, of course, is assuming you have a deeply mature process and everything's working end to end. Say you're the scenario where siloing happens very, very often, and as a QA, you're sitting there and your developer reaches over the proverbial wall, taps you on the shoulder, hey, I just deployed to test, can you run your scripts? What it's going to find, or what it's going to check for you, is whatever you've loaded into it. In that particular instance, if you've told it to check for it, it's going to help you. It's going to tell you, hey, there's a problem here, make sure you tell your developer. As for the second part of your question, do you think we can totally eliminate manual testing after all? It depends on your resources. The idea with automation is you can only put things in that you can programmatically check. So say, for example, you have marketing tests happening and your software as a service. As you're sitting there, marketing goes, hey, sometimes a customer is going to go down route A, and sometimes they're going to go down route B. If your automation can't determine which route it's on, you can't test it with automation. I probably shouldn't say can't. You could write a very gnarly script to make some kind of determining factor and run a different script each time. which is going to go against some of these principles we were discussing. The script itself would be very hard to maintain. If you had unlimited time and unlimited effort, we could test everything and we could even automate everything. But ultimately, you're going to find that return on investment is ultimately going to choose whether or not you automate that manual test, or if at the end it's just a quick 30-second test and you move on. Hopefully that helps.
Great, thank you for that, Chris. And I think we spoke to this, like I said, there were a few questions about the automation versus manual, but we did have another question in the chat asking if software can be 100% tested using automation, or if manual testing is still required in certain cases. And I think we did just get into that a bit in your answer to the earlier question.
Yeah, I can expand on that a little bit more, actually. When you're talking about complex situations, the idea with the automation is as long as you can programmatically harvest the data you're asserting against, we want to try to remove those complex scenarios. The big thing with complex or long-running tests is they're error-prone. We're all human. Sometimes we don't have enough coffee, or maybe too much, and we either click the wrong thing or we maybe miss something. The idea with automation is that if we have that script, we can press the button and walk away. The challenge here is knowing when you can get the right return on investment out of that script. Sometimes it doesn't make sense to automate it, even if it seems like a good candidate. In the particular situation I was talking about there, say you have a big spreadsheet you have to automate against. From an automation framework design standpoint, a data-driven test would be absolutely flawless here, especially if you can hook it up, press a button, and maybe it tests overnight for you. Maybe it's huge. The challenge becomes, how do you author the code in such a way that it doesn't bankrupt you or your team to maintain it? Or is it just a script that you're going to run one time? It's going to save you 35 hours of testing, and then you move on with your life. That's what you're going to have to be looking at when you're actually sizing this stuff up. If it's something that's going to be a one and done, that's where your ROI calc comes in. I do it once, it saves me 25 hours. Here you go, manager. We saved a ton of time. If it's something you're going to be running a lot, you can see, hey, I got to run this every time my developer changes code. Hopefully, he's not going to be changing code through a UI. Data-driven is not good for UIs for that explicit person or explicit idea. API testing is really where it's at for those, especially if you can throw in a ton of data and then move on.
Yeah, definitely choosing the right type of testing for the test case is definitely a conversation we have often here. Often enough that even I, over on marketing, am familiar with the concept.
Oh yeah, it is daily.
So I have just one more question on my end. Anyone else tuning in, if you have additional questions to share, please do post them now, so we can make sure we get them to Chris while he's with us today. Looks like I prompted someone there just coming in the chat. And I think that's a good one to read verbatim, since we have some clever spelling. In a fragile or agile development model with 2 to 3 week releases and ever-changing features to the last minute, how would you approach automating?
Perfect question. In fact, this actually kind of ties back to one of my slides where I was talking about the enterprise scale. Agile itself actually has its own test automation principles behind it. First and foremost, as part of true Agile, certain things are supposed to be divided or decided before the developers even start coding. Your data contracts, your URLs, stuff like that. They should, as developers, have the freedom to design the page roughly however they want, but they should be informing you as the automator, hey, this is going to be the sign-in page. We're going to have these buttons likely on the page, and that's going to be your data contract for the page. That way you and them can start at the same time when you're working in an Agile process. If they're using a extreme programming code first, they're not actually doing Agile development. When that happens, you start getting into Agile scope creep. People are continuously changing while the sprint's still active. The idea with Agile is you've come to a decision on what your MVP is going to be. You start working towards that MVP. And then if that MVP changes, you've already committed to that. At that point, your requirements are supposed to be stable. Now, supposed to and reality, two very different things. So in the scenario where your requirements keep changing, that's actually something you would broach with your team as part of your three amigos conversation. You, your developer, your product owner, say, hey, we're trying to do in-sprint automation here. And as part of this, we're not even able to start until maybe the second week of our sprint or third week of our sprint, et cetera, because things keep changing in such a grandiose way that we can't keep up. How can we, in Agile, redesign our SDLC process inside of this so we can specifically tackle getting this all done within our iteration? That's really what it's going to be like. Now, from the coding standpoint, it's about abstraction. It's about moving everything into methods so you can update bulk test cases at a time. Without that, you flat cannot keep up with bulk changes. It's not doable.
Great. And I think a little bit of a follow-on question to that, Chris, coming in now. Someone's wondering how to approach in-sprint automation.
So the big thing within sprint automation is communication first. If your teams are heavily siloed, and if you're even siloed inside of your teams, like developer to QA to product owner, that trifecta in Agile is called the three amigos. Automation itself, especially in sprint, requires that to be near flawless. Agile is based around the concept of everybody being subject matter expertise in your craft. If you're a junior automator, a junior developer, or a junior product owner, this starts to get a little wobbly. In order to successfully get through that, it now becomes about sizing your stories appropriately and having the conversations up front. You should have your minimal viable product that you're planning to release for your iteration. And even at the sizing ceremonies, you should be discussing with your team, hey, I want to automate this. These are the test cases I would like to automate. And ideally, you know already what these are going to be. If you've left your refinement process and you don't have an idea of your test scripts or what your even test cases are, you're not going to be able to do in sprint. The best you're going to be able to do is sprint +1. It's all about that agile velocity and agile conversations. If those are not happening on your team, again, that's broaching that conversation with your team, and the buy-in becomes necessary from those other two roles, QA to dev and QA towards product. Without those, it's, hey, this sprint, we didn't know the requirements until the sprint started. We've authored the test cases during the sprint, so we have no idea how much time it's going to take to run these. We're just now figuring it out. So next sprint, you can then put on your board, hey, we want to automate this stuff. Product owner, are these a priority? It's best you're going to be able to get.
Yeah. Yeah, no, it seems like Justin was talking about earlier, you're talking about now, that transparency, communication, making sure we're all on the same page.
It's what
right?
it's all about.
A long way. So we just have a couple of minutes left here. I do want to remind everyone, these slides and the session recording will be made available to you, since there is definitely a lot of great content in here, and I'm sure a lot of you are looking to get a little bit closer to it, especially with these resources on Chris's appendix. But as we send folks off, wondering, Chris, where would you advise people to start, right? You shared a lot of direction, a lot of information here. Is there a common challenge that you've seen, or a most effective action that you've seen teams take to move them in this direction of what is, of course, a long journey for test automation?
Yeah, so the most common problem I've seen, both at the different conferences, Star East, Star West, Agile DevOps, et cetera, typically you have the scenario where you have a legacy application a new manager has come in, et cetera, and they come in and say, hey, we want to do automation. The most common scenario I've seen so far is they want to do the automation, but the buy-in isn't everywhere. So you may have siloing like we were discussing before, specifically between the QA and these other roles on the team wanting to do it. The QA is receiving the pressure to do the automation, but the reality here is it's not an automation problem at this stage. It's still an agile and communication problem. When it comes to code, though, someplace to start, depending on the size of your company, you may have a scrum of scrums or something equivalent where you've gotten together and you've talked amongst yourselves to determine what are the requirements, what are the dependencies, is it one application, is it multi-application, is it microservices, et cetera. Typically, the first thing you have to do is figure out what your requirements for automation are. What's the language your company uses to pick that? What are the API interfaces? Or is it REST? Is it gRPC? Is it SOAP? What are you actually going to be doing for an automation framework? At that point, you're basically building an automation test strategy document. By the time you're done with it, you either should have a team level one or a company level one, depending on what your organization has. Some companies have center of excellence teams that specifically build these documents for people. They sit down, they talk to all the teams, they figure out, hey, this is the tech requirements you have, and then you go through and do that. Some of the bigger companies I've seen have completely siloed teams. And then at that stage, you're building it for yourself and anybody coming in. So say me and whoever answered that question are on a team, we'd sit down together, go through and, hey, we have these APIs. This is what it is. This is what we need. Start by figuring out what you have. Just like with the product teams, they need to know their requirements before they can start.
Great. Thank you for that. Start by figuring out what you have. I think that's good advice for test automation and so many other areas as well. Chris, that is the time that we had today, and just want to say thank you again for the presentation, for answering all those questions. Really appreciate you spending some time with us, and hopefully for those online with us today, they found this as helpful as I did. And again, we will be sharing all of this out with you in a couple of days. So Chris, thank you for joining us.
Thank you for having me.